This is SpaceTime, Series 23, Episode 80. Coming up on SpaceTime, discovery of the shredded remains of a mysterious ancient stellar cluster. NASA launches the most sophisticated ever mission to Mars, and bringing back the first ever samples from the red planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the shredded remains of an ancient globular star cluster that was torn apart by our own Milky Way galaxy more than 2 billion years ago. This extraordinary discovery, reported in the journal Nature, is composed of stars which have a very different chemical composition to all other known globular star clusters. Globular clusters are primordial gravitationally bound balls containing hundreds of thousands to millions of stars, all originally formed at the same time out of the same gravitationally collapsing molecular gas and dust cloud. They're usually found orbiting in the stellar halos surrounding galaxies. The Milky Way is home to at least 150 globular clusters, some of which are suspected to be the cause of ancient dwarf galaxies that have been cannibalized by the Milky Way. And globular clusters are old, some as old as the Milky Way itself. This newly discovered dismembered globular cluster was found in the direction of the constellation Phoenix. Its shredded remains represent a unique archaeological find, as the stars have far lower metallicity than any other known globular clusters. Astronomers refer to all elements other than hydrogen and helium, the elements created in the Big Bang 13.8 billion years ago, as metals. The first generation of stars to have existed began to shine around 13.5 billion years ago, changing the universe forever. And they were made out of almost pure hydrogen and helium, the only elements to have existed in any substantial amounts at that time. They in turn produced the first heavier elements in the universe, either during their lives or in their deaths. And it's these elements which then went on to seed subsequent generations of stars over many billions of years, eventually creating life. One of the study's authors, Professor Grant Lewis from the University of Sydney, says evidence of the much lower quantities of heavier elements in the Phoenix cluster strongly suggests that the original structure was the last of its kind, a globular cluster whose birth and life was very different to those remaining today. Lewis and colleagues from the Southern Stellar Stream Spectroscopic Survey, or S5 collaboration, were using the Anglo-Australian Telescope in far western New South Wales to measure the speeds of a stream of stars in the Phoenix constellation, discovering it to be the remnants of a globular cluster that was pulled apart by the gravity of the Milky Way about 2 billion years ago. Studying the composition of the stars in the stream revealed their unusually low metallicity, making them distinctly different to all the other globular clusters in the galaxy. Observations of other globular clusters have found that their stars are enriched with heavier elements forged in earlier generations of stars. Current formation theories suggest that this dependence on previous stars means that no globular cluster should be found unenriched, and that there's actually a minimum metallicity floor, if you will, below which no globular cluster can form. But the metallicity of the Phoenix stream progenitor sits well below this minimum, posing a significant problem for the ideas of globular cluster origins. Astronomers can trace the lineage of stars by measuring the different types of chemical elements in them, much like tracing a person's connection to their ancestors through their DNA. And the most interesting thing about the remains of the Phoenix cluster is that its stars have much lower abundances of these elements than any others ever seen. It's almost like finding someone with DNA that doesn't match any other person, living or dead. And that leads to some really interesting questions about the cluster's history. Lewis says that so far there's simply no clear explanation for the origins of the Phoenix stream progenitor. So where it sits in the evolution of galaxies remains unclear. While potentially numerous in the past, this population of globular clusters was steadily depleted by the gravitational forces of our galaxy, which tore them to pieces, absorbing their stars into the main body of the galactic system. This means that the Phoenix stream is a relatively temporary phenomenon which will dissipate over time. Astronomers therefore are lucky to find its remains before they fade forever into the galactic halo. In astronomy, whenever scientists find a new kind of object, it always suggests that there are more like it out there, somewhere. While globular clusters like the progenitor of the Phoenix stream may no longer exist, their remnants may still live on as faint streams. So the next question to ask is whether there are more ancient remnants like that out there, the leftovers of populations that no longer exist. Finding more such streams will give astronomers a new view of what was going on in the early universe. Lewis says that means there's plenty of theoretical work left to be done and many new questions to explore about how galaxies and globular clusters were formed.
We're just catching Phoenix in its death throes. It's only got a few more orbits to go and it will be gone. Whereas the present population of globular clusters that we see, they came in at another time and from environments where there were more chemical elements. So what we think is that Phoenix has given us a bit of a window on the earliest epochs of galaxy formation, exactly what was the Milky Way built of. So, it's kind of exciting to find, like, it's almost like finding the last Neanderthal or a population that will become extinct and you just find the last member of them.
It looks like the Milky Way right now is cannibalizing at least 4 dwarf galaxies we know of. There's the Large and Small Magellanic Clouds, there's Canis Major Dwarf Galaxy, and there's the Sagittarius Dwarf Galaxy. They're the ones it seems to be snacking on at the moment. Phoenix doesn't fit in with any of those streams, does it?
No, it doesn't appear to have come from any of those objects. Somebody did contact me the other day and said that there is as well as the ones which are obviously being eaten now, there are people that are trying to pick apart the remnants to see when other dwarfs might have fallen in. And so Phoenix may be related to some other structures in the halo, but as of yet, we only really started putting the jigsaw together, and we've got a lot more work to do to really understand where Phoenix came from.
Can we determine anything by its movement across the sky, how these stars are moving in relation to other stars in the Milky Way?
Yeah, we can. So we can trace, so we have its velocities from our spectroscopy, and you can also get an estimate of the speeds of the stars using things like the Gaia satellite, which is measuring proper motions. So we have an idea of what the orbit looks like, and it does pass coincidentally, suspiciously near another structure in the constellation of Hermes. Whether or not they're truly related, again, we do not really know. But we have an idea of the orbit. One of the big problems we have, though, is that we have a bit of a double-edged sword here. We want to use the orbit to work out how much dark matter there is in the galaxy, and unless you know how much dark matter there is, you can't say you've accurately worked out how the orbit has gone over many billions of years. So we need to build up the two pictures at the same time. So there are some suspicions, but nothing is rock solid at the moment.
What are we hoping to find out about Phoenix?
We want to go deeper. So look, it's the usual astronomy tale, right? You ask an astronomer what you need. You need more data. So we've already gone to bigger telescopes to get high-resolution data. So there are my colleagues, it's not my area of expertise, but my colleagues that try and understand the detailed chemical makeup of the stars, various elements in the atmospheres of stars can tell you precise clues about how the thing has evolved. So we're getting that data. Of course, what we also want to know is Phoenix the last? I mean, if we look more deeply into the halo, maybe there are fainter globular clusters out there that we haven't quite picked up yet, and we will see that maybe there are a couple of other members out there. What we're doing in this particular survey now is that we actually are gathering data for tens of these streams. So we are taking data regularly between now and at least the end of the year to get data on more streams. So we are going to be trying to put together a bigger overall picture with regards to things like the shape of the dark matter halo and how the Milky Way has grown over time. And one of the big questions will be, where does Phoenix slot into this picture? And where did objects like Phoenix, where do they sit in terms of building the Milky Way?
What does the lack of dark matter in globular clusters tell us about their origins?
Yeah, that's a good one. And I was explaining to my colleagues, I'm getting rather tired of saying that we don't really understand globular cluster formation. But what it tells you is that, let's think about where stars are forming in the universe today. So stars form in the disks of spiral galaxies. That's where the gas is, in that flat plane, and it's swirling around, and that gives you the environment in which you can create stars. Now, with the globular clusters, right, these are big objects, right? At least 1 million times the mass of the sun. So to make them, what you need a big chunk of gas to collapse down in one go and form a ball of stars all in one spot. And we don't really have many places in the universe where you can create that kind of environment. Sometimes when galaxies collide, we think you can get the sites of forming globular clusters. But what people think is that in the early universe, before gas collapsed down into disks, then there would be a larger distribution of gas around galaxies, and other things sort of started collapse in parts of the gas. So you can have shock waves through the gas or various kinds of motion through the gas that means that it would break and fragment into a chunk about 1 million times the mass of the sun, and it shrinks down to give you a globular cluster. So yeah, they are definitely forming in places that we don't have around us today. But it's a big question internationally. What are globular clusters? How did they form? And what are they telling us about the overall formation of galaxies?
It's fascinating how our understanding and knowledge of astronomy is evolving and changing from globular clusters being formed out of a single molecular gas and dust cloud collapsing at once in the early universe to understanding that there's more than one generation of stars in most globular clusters now. Originally it was just the one generation, we thought. Then came this idea of, well, maybe some globular clusters are the cause of other galaxies. And now, thanks to Gaia and studies like this, we're learning so much more about the early history of our own galaxy.
Absolutely. And of course, I mean, it's not a surprise that the picture is more complicated than we initially thought, right? I mean, the early ideas of how a galaxy formed is like one big thump of gas coming together. Now we see that there are all these different players and they're all playing various kinds of roles. And I said that notion that at least some of the globular clusters are the cause of other dwarf galaxies. The overall picture may take us a long time to completely unravel to see how the Milky Way grew. But, it's turned galaxy formation from a very simple picture into something more like climate science where, there's all these different parts and pieces you've got to consider to build up a galaxy like the Milky Way over time. But of course, like all good science, is that the more questions we think we've answered, the more questions there seem to be to answer.
The more we learn, the more we realize we don't understand it all yet.
Absolutely.
That's Grant Lewis from the University of Sydney. And this is SpaceTime. I'm Stuart Gary. Still to come, NASA launches the most sophisticated mission ever to Mars and plans to bring back the first ever samples from the red planet. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
After more than a decade of preparation, NASA's Mars 2020 Perseverance rover mission has finally blasted off on its way to the Red Planet to search for signs of alien life. NASA's most sophisticated ever mission to Mars was launched aboard an Atlas V rocket from Space Complex 41 at the Cape Canaveral Air Force Station in Florida on a 7-month, 500 million kilometre journey, which, all things being well, will arrive on the Martian surface on February the 18th, 2021.
8, 7, 6, 5, 4. Engine ignition, 2, 1, 0. Liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed-loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed-loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload-bearing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload-fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill-down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly. And we have BECO, booster engine cutoff. Standing by for stage separation. And we have good indication of Atlas Centaur separation. And we have MES-1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length. And we have seen the Centaur PU system go to closed-loop control. Engine response remains nominal, still seeing stable and nominal chamber pressures. And we are beginning to see the RCS system begin periodic thermal firings to maintain conditions in the loop. And the loop and bottle temperatures are beginning to converge on nominal temperatures. And initial data review of boost flight indicates slightly above nominal performance of the Atlas V booster. At this time, the vehicle is 140 miles in altitude, 900 miles downrange, traveling at 14,500 miles per hour. And we have successful separation of Mars 2020 with the Perseverance Rover.
The Atlas V Centaur upper stage initially placed the spacecraft into a parking orbit around the Earth. The spacecraft then separated from the Centaur, setting course for the red planet Mars. However, shortly after leaving Earth orbit, the spacecraft suddenly lost telemetry, entering a safe mode and raising concerns back at Mission Control at NASA's Jet Propulsion Laboratory in Pasadena, California. The spacecraft's designed to place itself into a safe mode if its onboard computer systems perceive conditions are no longer within its preset parameters. When a spacecraft enters the safe mode, all but essential systems are turned off until it receives new commands from mission managers. Mission managers at JPL say the unexpected switch may have been caused by the spacecraft becoming colder than expected while flying through Earth's shadow. Now it's well beyond Earth's shadow, all temperatures have returned to normal. Mission managers say they're now completing a full health assessment of the spacecraft and are working towards returning the probe to normal cruise configuration for its journey to Mars. If everything goes as planned from here on, the mission will eventually land on an ancient river delta inside the 45-kilometre wide Jezero crater just north of the Martian equator. Once on the ground, Perseverance will search for signs of ancient microbial life on Mars and explore the diverse geology of its landing site, collecting samples for eventual return to Earth. The SUV-sized 6-wheeled rover, which is based on the highly successful Mars Curiosity rover, which is currently exploring nearby Gale crater, will also test a system designed to harvest oxygen directly out of the Martian atmosphere for future manned missions to the red planet. It'll test the performance of different materials for use in future Martian spacesuits. It's carrying a microphone which will allow us to listen to the sounds of Mars, and it will launch InSight, the first helicopter to fly in the air of another world. The mission's Jezero Crater River Delta Lakebed landing site was chosen because it contains lots of silt from rocks, minerals and debris that would have flowed in from the surrounding landscape, thereby providing a rich palette of material to study. A perfect place to search for signs of interesting geology and possibly also signs of life if it ever existed there. This report from NASA TV.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And that report from NASA TV featured JPL Perseverance Deputy Project Scientist Katie Stack-Morgan, as well as Caltech Perseverance Project Scientist Ken Farley. But while the road to Mars isn't an easy one, this time round the road just getting to the launch pad hasn't been very easy either, what with the COVID-19 coronavirus pandemic having a major impact on the mission's preparation. It meant both developing the most sophisticated Mars mission ever flown, while at the same time keeping the people working on the project safe from the deadly virus.
This new rover will search for signs of ancient life, test new technologies, and gather rock samples which may someday become the first pieces of the red planet ever returned to Earth for analysis.
Today we are naming a spacecraft that will go to Mars, and the name is Perseverance!
When Perseverance was first selected, I wasn't sure about it, to be honest.
When the pandemic struck, the future was certainly unknown. It was like walking into a blind, dark alley. You didn't know what was there, what was in front of you, what you were going to have to deal with.
It's something that nobody expected. It's something that nobody could plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
And it took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
We called the effort Mars 2020 Safe at Work, and the objective was to keep the team as safe or safer than they would be if they were not working. You know, putting a spacecraft together that's going to Mars and not making a mistake, it's hard no matter what. Trying to do it during the middle of a pandemic, it's a lot harder.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids. Sometimes I'm not able to focus or listen probably as well as I would want to.
A lot of our work was occurring in a clean room anyways, but that meant that even before we entered the clean room, we had to find ways of ensuring that we were not putting ourselves or others at risk.
We're really doing something that's transformative and trying to understand whether or not life evolved on another planet. That's the fundamental objective of this mission.
We are explorers. Our job is to go into the unknown, and this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
You know, I'm a convert now. Perseverance is the right name for the rover.
It's an amazing serendipity that we get to persevere through working on Perseverance.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance plate that's now affixed to the port side of the rover. It has a symbol, a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community on the front lines, keeping us safe. And we hope that this plate and we hope that this mission in some small way can inspire them in return.
And that report from NASA TV also featured JPL Perseverance Deputy Project Scientist Katie Stack-Morgan, as well as NASA's Mars 2020 Assembly Test and Launch Operations Manager Dave Gruhl, Mars 2020 Mission Deputy Project Manager Matt Wallace, Perseverance Chief Engineer Adam Stelzner, and Project Systems Engineer Ian Clark. This is SpaceTime. Still to come, plans to bring back the first ever samples from the red planet Mars, and later in the science report, Monash University develops a new preventative drug against heart attack which could also provide a treatment for COVID-19. All that and more still to come on SpaceTime. One of the many duties of NASA's Mars 2020 Perseverance rover will involve the collection of soil and rock samples for eventual return to Earth. While samples from the Moon, from near-Earth asteroids and passing comets and even the solar wind have all been successfully collected in situ and returned to Earth for study by eager scientists, returning samples from the red planet Mars will be our biggest challenge yet. It will be the first ever sample return mission to Mars, and the most distant sample return mission ever undertaken. It will also be the most important. That's because it will be laying the groundwork for future manned missions to the red planet. After all, if you can't get a bunch of rocks back to Earth from the surface of Mars, how are you ever going to be able to get people there and back? And the job of getting those first Martian rock samples back to Earth has been entrusted to the European Space Agency. ESA has now contracted Airbus to build an Earth return orbiter spacecraft for the return journey to Mars. ESA's Director of Human and Robotic Exploration, David Parker, says the plan isn't just twice as difficult as any typical Mars mission, it's twice squared because of the complexity involved. The The 6,500-kilogram Earth Return Orbiter spacecraft is slated to launch in 2026 using ion engines to travel to the red planet and back again. Once in Mars orbit, a NASA-supplied landing craft transporting a European rover will descend down to the surface. The rover will then find and retrieve the Perseverance return samples, which will be in a series of special containers. They'll then be loaded into a basketball-sized capsule fitted on a Mars ascent vehicle which is mounted on top of the landing craft. It will then launch back into orbit, where it will rendezvous with the Earth Return Orbiter. The orbiter will then fly back to Earth, releasing the sample return container to parachute down into the Utah desert in 2031. Of course, that's assuming that every complicated step of the mission works just as planned. This report from ESA TV.
The planet Mars has been mysterious for centuries. But over the past few decades, a fleet of orbiting and landed spacecraft has greatly advanced our understanding of it. Based on this knowledge, Mars scientists are now ready to take the next big step, bringing Martian samples back to Earth, where the full power of our terrestrial laboratories could be applied to unlocking the story of the red planet's geology, climate, and especially its potential for life, either in the past or even today. But however you tackle it, returning samples from Mars is definitely a complicated problem. So how could we actually get a sample from Mars? One approach is to use a series of 3 spacecraft working together like a relay team to deliver samples to Earth. NASA's Mars rover will acquire a set of carefully selected samples of rocks and surface material and store them in sealed tubes for possible return to Earth. NASA and the European Space Agency are now working together to explore options for a pair of missions that could take the next steps to bring these samples back. In one scenario, after the Mars 2020 rover has placed its collected samples on the Martian surface, a second follow-on mission would land nearby, deploy a small rover to fetch the samples, and bring them back to the lander, where they would be loaded into a container and placed atop a small rocket. The rocket would then lift off, carrying the samples up into Mars orbit. Waiting in orbit would be a third spacecraft, an Earth Return Orbiter, that would find the samples in space, catch up with them, capture the container, and bring it back to Earth. With Mars samples safely back on Earth, scientists around the world would be able to study them in state-of-the-art laboratories for decades to come. The payoff of a sample return would be a breakthrough in our understanding of the history of Mars and of the potential for life beyond our home planet.
And time now to take a brief look at some of the other stories making news in science this week with a science report. Researchers at Monash University have developed a new drug which can potentially be given as a preventative against heart attack. The drug blocks minute changes in blood flow that preempts a heart attack by targeting an enzyme which allows the platelets to respond to blood flow changes, preventing them from triggering clots before they can kill or cause damage. A third of all deaths globally, 18 million a year in fact, are caused by cardiovascular disease, largely heart attack or stroke, both of which are triggered by clots blocking vessels in the brain or heart. While drugs like aspirin given at the time of the attack can prevent further clots from forming, they only work in 25% of cases, and these drugs can cause serious side effects from bleeding. The findings, reported in the journal Science, may also have a role in preventing the clotting that's a hallmark of the COVID-19 infection. Well, you think we would have learnt something from all the science fiction horror movies out there, but it appears not. Scientists have now successfully revived dormant microbes that have been trapped beneath the seafloor of the Pacific Ocean for more than 100 million years. A report in the journal Nature Communications found that up to 99% of the ancient microbes, which date back 101.5 million years, were successfully revived once they were given a bit of carbon, nitrogen and oxygen to feed upon. The bacteria were extracted from sedimentary drill core samples taken from up to 75 metres below the seabed, which itself was some 6 kilometres below the ocean's surface. The samples have been collected from a 2020 expedition aboard the Jody's Resolution drill ship to the South Pacific Gaia, a lifeless trash vortex at the centre of swirling currents thousands of kilometres to the east of Australia. Scientists found there are no limits to life in the old sediment of the world's oceans, all the way down to the underlying basement rock. A new study has found that Australia's deadly summer bushfires were so severe that their smoke reached new heights in the atmosphere, causing strange, never-before-seen reactions globally. A report in the journal Geophysical Research Letters found the wildfire infernos fueled a type of huge thundercloud called a pyrocumulonimbus, which drew between 300,000 and 900,000 tons of smoke into the stratosphere, more smoke than seen in any previous fire ever recorded. And this plume rose to record heights of more than 31 kilometres, spanning more than 1,000 kilometres across and being propelled around the globe by never-before-seen 54 km/h winds, the origins of which remain a mystery. The rising plumes also lifted up record amounts of water and carbon monoxide, at the same time also displacing ozone-rich air from the stratosphere, an important gas used to blanket the Earth's surface from the deadly effects of ultraviolet radiation from the sun. A bit of good news now, and a new study has confirmed that eating chocolate at least once a week was linked to a reduced risk of heart disease. The findings, reported in the European Journal of Preventative Cardiology, suggest that chocolate helps keep the heart's blood vessels healthy. The new research follows earlier studies showing that chocolate's beneficial for both blood pressure and the lining of blood vessels. Scientists conducted a combined analysis of studies from the past 5 decades, examining the association between chocolate consumption and coronary artery disease. The analysis included 6 studies with a total of 336,289 participants who reported their chocolate consumption. They found that compared with consuming chocolate less than once a week, eating chocolate more than once a week was associated with an 8% decreased risk of coronary artery disease. Chocolate, you see, contains heart-healthy nutrients such as flavonoids, methylxanthines, polyphenols, and stearic acid, which may reduce inflammation and increase high-density lipoproteins, the good cholesterol. Nowhere in humanity is the difference between knowledge and wisdom better illustrated than in the Nobel disease. No scientific award is more coveted than the Nobel Prize. This prize, in the eyes of the public, especially in the 3 traditional science categories of physics, chemistry, and medicine or physiology, is virtually synonymous with scientific brilliance. But the Nobel disease is proof that intelligence fails to protect you against stupidity. Tim Mendham from Australian Skeptics says the stories of more than 600 Nobel laureates in the hard sciences poses a question that bears intriguing implications for the field of skepticism. To what extent do remarkable levels of intelligence seem to immunize individuals against equally remarkable lapses in critical thinking?
Yeah, it's a thing where, I don't know, you can try to apply psychological theorising to this.
Is it the Dunning-Kruger effect
because
again?
There could be the Dunning-Kruger effect, but yeah, because you've been lauded, you've done a lot of research, you've won a Nobel Prize, you probably deserve to win it, etc., and suddenly you can do no wrong, and therefore you go from subject A to topic Q, and you think that because I know subject A and I've been lauded and awarded for it, that therefore I should be able to talk about subject Q with impunity and as an expert, and often the things that people believe in are sort of way outside their area of expertise, and certainly way outside the area of science. Some of the examples of some of these people suffering the Nobel disease, as they call it, which is Linus Pauling, who's actually one of the few people to have won the Nobel Prize twice. He won it for chemistry, and then later on he won the Peace Prize. But he's become the architect of the vitamin C campaign, that the more vitamin C you take, the better you are healthier. And yet there's no evidence that actually vitamin C can treat the common cold, as I say, and that it doesn't have all the health benefits that he's claiming. That's right. Too much of anything is toxic, actually. It's a strange one. William Shockley is one of the weird ones. Anyone who knows your electronics knows that Shockley invented the transistor. I don't mean the radio, I mean the thing that's inside your computer, which is probably one of the most important inventions of the last 100 years. And yet he's gone into all sorts of areas, mainly into racial stereotyping, and that nature has colour-coded groups of individuals so that you can tell who's going to be most intellectual and who's not. So he talks about retrogressive evolution. So, I mean, he's gone from physics Nobel Prize for something which is vitally important and quite innovative technology into straight-out emotional unsubstantiated racism, and all racism is unsubstantiated anyway. Yeah, so I mean, it's just strange. James Watson, who's sort of Crick and Watson, who one of three people who, yeah, that's right. He's gone much the same way on racist ideas and things, and he thinks that higher levels of melanin means you have a stronger sex drive, that obese people are less ambitious than other people. Certainly they don't exercise so much, perhaps, but and that blacks are inherently less intelligent than whites. So he's gone from his genetic research, etc., on DNA, pretty important stuff, to really being out there. And there's an article in the Skeptical Inquirer, which is the US equivalent of the Skeptic magazine that we have in Australia, that I'm proud to be the editor of, that lists a whole lot of Nobel Prize winners, and far too many to go through here, and about how they've gone off the deep end. And there's a huge range of them, some of them going in weird, impossible technology, perpetual motion machines, some into sort of racist and genetics and that sort of stuff, some into all sorts of health cures and everything, which are unsubstantiated. It seems to be, but I've known people who are professors of particular areas who believe the most outrageous things. And whether that's a characteristic of being a highly rewarded, awarded, noticed science in a particular area that makes you feel that you are entitled to talk about other things, or whether it's just a belief that they can't be fooled because they've done all this research and they're a scientist, they have a scientific approach. They can be, and you will always find a scientist somewhere with a PhD, whatever, to endorse some of the most outrageous things.
Yeah, just get your PhD from the University of Wollongong.
Yes, exactly. People sort of who are happy to step outside of their proper expertise. I actually, for your info, way back when Ron Daniken first came out with the Chariots of the Gods theory, it was the ancient aliens theories, etc., total BS. And after the first week, a lot of people wrote in, and I noticed this actually. They said that I'm an archaeologist and his archaeology is rubbish, but his astronomy is great. And someone else wrote in saying I'm an astronomer, his astronomy is rubbish, but his archaeology is great. And basically, one, it shows that if there's an expert out there, be careful who will pick you up, but also that a lot of experts don't know other stuff, and they should stick to their area of expertise.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.